Hey, hi everyone. Good morning, good afternoon, or good evening, depending on where you are. How are you all doing this morning, today? Thanks for joining us for this session. We'll talk about Java. We'll talk also about how your attack surface just got bigger with the amazing Micah today. So without any further ado, over to you, Micah.
Hello and good morning, afternoon, evening, like Sonia said. And glad you could join me here in my office. You might see some dogs in the background, although I'm keeping the background pretty dark here. But let's jump right into it. So, where you are is a session we call Stranger Danger. Your attack surface just got bigger. And this is going to focus on Java, but it's really generally applicable. If you're a developer, you're in the right place. Just a little bit about me. I have been programming in Java since it was released 27 years ago. This is usually the part where I say, get off my lawn. I'm also an author. I got to co-author this book on mastering enterprise Java beans just in time for that technology to be irrelevant, but it's something I'm still very proud of. I'm an open source contributor. I'm a DevSecCon chapter leader. If you don't know what DevSecCon is, it's our standalone organization to bring together developers, DevOps, DevSecOps people in a room, and we do live meetups, and we have chapters all across the world. I like to build things. I pictured here as a full standing, freestanding MAME arcade cabinet that I built back in the day. And last thing that's good to know about me is I am a chaotic neutral. That's a Dungeons and Dragons term if you're not familiar with it. That's my character alignment. It's also my alignment in real life. And all that means is that I like to mess around with people. I'm a practical joker, but I do no real harm, at least if you ask me. Some other people might disagree, but it's a perfect sort of alignment for the types of things that we're talking about because I like to poke and prod at systems, especially Java-based systems, to see where there may be vulnerabilities and how we can go about fixing them. So what is the problem space that we're dealing with here? Well, especially in the world of Java, well, I guess everywhere, software delivery has sped up. Now, back in the day, being a Java developer, working for banks and insurance companies, we released once a quarter. And we would work and work and work, and then we had a small window to release. And if something went wrong, we had to scramble. If we missed the window, it required all kinds of escalations, and it was a challenging time to be a developer. Now, we sped up that software delivery lifecycle, which on balance has been a very good thing. We work on much smaller chunks of work. We release maybe once a month now, or sometimes even we can release at will. But with all that, there's been very little thought to security. And there's a lack of security focus throughout the app lifecycle, usually, especially when you're talking about big banks and insurance companies. But I think in general, you have this siloed security expertise. And even though we've sped up our software delivery, we find ourselves in a position where still at the last minute, we're getting a security audit and maybe something's getting kicked back to us. And there has been this kind of traditional tension between developer teams and those teams responsible for security. And of course, the biggest problem is customer data can be compromised, and we've seen no shortage of those kind of stories, and they're not going away. It's not like we've completely learned our lesson and everything's better now. So if we look at the scope of the situation, we can start with our modern application. And we love our iceberg metaphor here. If, in case it's not clear, what we're building on the left here is an iceberg. And when we look at just the very tip of the iceberg, 10 to 20% of our code is custom code. So if you're like me, I have a tendency to think of my application as the code that I've written, but that really is only 10 to 20% of the code. And developers are really focused on features and not so much on security. Features, features, features. And if security's in there at all, it's kind of an afterthought. Now we can have a very clear and immediate example of this. Here's a little Java controller code snippet. And you may already be able to see that there's a problem with this code. And if you're around, feel free to drop in chat what the problem might be with this code. but we're going to have a chance in just a little bit to do some interactive work together. So for now, I'm just going to press on and show you that this is a classic case of cross-site scripting vulnerability. It could also be an entryway for things like SQL injection. The problem here is that we're taking an input and we're passing it directly to a function without any sort of sanitization. Now, this is a very simple example, but if you're developing hard, if you're working on these features, you might miss something like this in a more complex situation. And of course, cross-site scripting aren't the only types of vulnerabilities we can introduce into our code. The next layer down on the iceberg, what's below the surface, are our open source dependencies. And we find in our analysis that's in a modern application, somewhere in the range of 80 to 90% of the code base is going to be these open source dependencies. And what was news to me, I would imagine that if I'm bringing in a library, that library may have security vulnerabilities. Even before I joined Snyk, I might have imagined that as a savvy developer. What was surprising to me is that 80% of the vulnerabilities are found in indirect dependencies. That is, the dependencies of the dependencies. So if I'm bringing in a library like a markdown library, because I don't want to reinvent that wheel, I might not be surprised that that markdown library has some vulnerabilities. They're always, it's a cat and mouse game. We're squashing new vulnerabilities and new ones pop up. But the markdown library I'm using itself has dependencies. Maybe it's got some sort of code parser or some sort of pretty printing library that it's using. And 80% of the vulnerabilities are going to come from those dependencies of dependencies. All right, without further ado, let's hack together. I'm going to leave this URL up just for a second, but it's snyk-chat-goof.herokuapp.com. We're coming to the end of the time that I can use this as in its current deployed state. I'm going to have to find an alternative RIP free Heroku. Now I'm going to switch over to the browser, but I'll highlight this URL once again so that you can get there. It's snyk-chat-goof.herokuapp.com. Go ahead and put in a username. It doesn't have to be your real name. And this is what we're looking at here is a modern chat app. We're going to dig into the code a little bit, but you can add new rooms like a modern chat app could, but I'd like you to go to the main room and start chatting. Now, currently only I'm here. Hopefully a few more of you will join because it's more fun when it's interactive. But this is just simply a chat app. So I can say hello. I can type in messages. Like for me, it's the morning. So I will say good, very early morning. Awesome. We got Dev Steve in the house. Awesome to see you, Dev Steve. Miss you, buddy. And one of the other features, so just to talk a little bit about what we're looking at here, and please forgive me my design chops. I'm more of a back-end developer, so don't hold the way this looks and feels against me. But what we're looking at is a modern app. That is, we have a JavaScript front end. We have WebSockets in between so that we can all see what we're chatting, and we have a Java backend. Now, this chat app also supports Markdown, which is great. Markdown allows me to start adding some fun flair, if I can spell it right, to my code with some simple, terse syntax that allows me to do things like that's a single italics or a single underscore. Double star gives you bold. So it allows us to have a simple syntax to make the text, our chat, a little more rich. So with that in mind, if you're like me, if you're a chaotic neutral, anytime I see an input on a website, I want to start messing around with it. And of course, this is kind of like the hello world of scripting attacks. We want to see if we can inject JavaScript into this. If I can inject JavaScript into the chat, maybe I can mess around with this application and mess around with other people. So this is the very first thing that I'm going to try. I'm going to try to inject a script tag. Pretty straightforward, pretty low-hanging fruit. And the good news from a security perspective is that there's some sort of sanitization going on because my tag is not being interpreted as a tag. It's being converted into visual text that we can see on the screen. So rather than getting a pop-up alert, it just passed through what I typed literally so that we see it in chat. Now that's very good from a security perspective, but I'm not done yet. For everybody that's here, welcome. Lucy, Davis, Dev, Steve, Sonia, thank you for joining. Feel free to hack around at this. I have a prize for anybody that can break this app, but there are some ground rules. The ground rules are it can't be a denial of service attack because this is running on a soon-to-be-gone free tier on Heroku, and it would be really easy to make this fall over by just flooding it with requests. But if you can do something clever with JavaScript or break the backend so that we no longer see chats, that's not a denial of service attack, then I have a special prize for you. So feel free to hack around. In the meantime, in case you're not familiar with it, Markdown also supports links, right? Very handy to have links on a page. And so this is the syntax of it. It's a square bracket with a label followed by parens with the URL in it. And one quick caveat here, when I hit enter, what's going to happen is there'll be a link rendered on the page, but there is no officially supported part of the Markdown spec that allows you to open a link automatically in a new tab. I think that's kind of a shortcoming. So if you click on this link, it's going to take you away from the chat. So rather than click on it directly, you can right-click and choose Open Link in New Tab, and then it just functions like a normal link. We get to the front door of Snyk's website. So, and this is useful for a modern chat app, right, to be able to send links around to each other. But this may give me a nice entry point into messing around with JavaScript again. So this is a perfectly valid link, and if I can get this past the sanitizer, then maybe when you click on it, I can get you to get an alert up on your screen, which will mean that I've been successfully able to inject JavaScript. So I'm going to push this through, and this is very interesting. This tickles my chaotic neutral spidey sense, as it were, because I wasn't successful. I don't see a link that you can click on, but I do see a closed paren. To me, that means that I've made progress. Now, I might be wrong, but I'm thinking I've made progress here, and maybe I'm starting to break the sanitizer. So let's see what else we can do here. And I'm going to put in some code and then explain what that is. So bear with me a second. All right, now if anybody recognizes what I've just altered the code to be, drop it in chat. But in case you're not familiar with it, what we're looking at are some HTML entities. An HTML entity starts with an ampersand pound, followed by a number, followed by a semicolon. Now this is in fact what's happening behind the scenes when we're rendering things like tags. Behind the scenes, the sanitizer is converting that left arrow to its HTML entity equivalent so it will be rendered on the screen and not interpreted as part of a tag. So browsers support interpreting HTML entities as characters, and here I have the HTML entity for a colon and the HTML entity for a closing paren. So what I'm hoping is there's some sort of sanitizer. We already know that. And maybe the sanitizer is looking specifically for the string JavaScript colon and is then filtering that out or altering it. So what I'm hoping is that if I'm using the HTML entity instead, that's going to sneak past the sanitizer and allow us to mess around with this in some way. So let's see what happens. All right, not successful, but maybe more progress. Now it looks as if the sanitizer's given up altogether. It's not even trying to render what I'm putting through. Now that may mean that the sanitizer's decided that it can't properly sanitize my chat, so it's just not going to put it through, or it may mean that the sanitizer is breaking in a certain way. Being a chaotic neutral, I'm going to go with the latter and assume that I'm breaking it in some way. All right, last iteration here. And let's take a look at what's happening. Now, spoiler alert, this is going to work. And we're going to look and see what's going on here in just a moment. But the interesting thing here is that this is taking advantage of a combination of a problem with the sanitizer and the browser being too permissive. What I mean by that is &#58 is no longer a valid HTML entity. But the browser will happily interpret this as a colon, even though it's no longer valid. And amazingly, as developers, we know if we have a syntax error, we're just going to get an error. The compiler is going to blow up at us, especially in Java. Maybe not so much JavaScript, but still, even in JavaScript, if we have an egregious syntax error, something's going to break. Well, in your browser, it's going to do its darndest to help you out. And in this case, it's going to interpret &#58 as a colon. So let's assume we're going to sneak this past the sanitizer. We now have JavaScript colon, and then the keyword this. This is a keyword in JavaScript. It's often misunderstood, but it's perfectly valid. So syntactically, we don't have a problem here. Then we have a semicolon, which is the statement separator in JavaScript. So far, so good. Then we have an alert, and then a 1, and then a close paren. So if this sneaks past the sanitizer, I will have successfully injected JavaScript into the chat. And I have. So now I can see when I click on it, I get an alert. And it's worse than that because if you click on it, you'll get the alert also. And you might be inclined to say, well, big deal, it's just an alert. But a lot of hacking involves foot in the door kind of operations. Now that I have a foot in the door where I know that I can inject JavaScript, now I might try to do something more serious, like maybe I can tease out a way to show me all of your cookies, or exfiltrate your local storage, or start to mess around in that way with JavaScript. So what we're looking at here is a classic cross-site scripting attack, and it took kind of some serious trickery to be able to do it. Now we're going to take a look at the code here, and I want to show you that as a responsible developer, I am not reinventing the wheel. Here I'm using a library called marked. Let me just make that a little bigger. I'm using a library called marked. This is very simple code. I'm setting up marked, and I'm making sure that the sanitization is true. Now, as a security professional, this tickles my brain a little bit. It would be nice if this library had sanitization on by default, kind of a deny first approach. And then if we, for whatever reason, wanted to explicitly turn off the sanitizer, we would have to pass this in as false. But I'm being a responsible developer. I read the documentation, and this is what I need to do to make sure sanitization is on. Then, whenever a message comes into this chat app, it's going to pass it into this marked function so that if there is any markdown, it'll render it. So 3 lines of code: import, setup, and then usage. And now this is the benefit of open source. I don't have to reinvent the wheel of Markdown. But as we just saw, there's now this problem of cross-site scripting attack. So as developers, how can we be confident in the open source libraries that we're using? How can we continue to develop fast but have a high degree of confidence in the security? Well, the first thing I want to show you here is Snyk Advisor. And Snyk Advisor allows us to search for libraries across a number of ecosystems. Currently, it's NPM, PyPy, Go, and Docker. So I know we're going to shift gears and get into Java in just a moment, I promise. But hopefully we'll be adding more ecosystems. But the nice thing is if you're a Java developer, you're almost certainly encountering JavaScript as well in one form or another in order to build a modern app. And so the nice thing is I can do a search. Like, let's say I want to find the best Markdown library to use in my modern application. Well, here we give you a very clear package score. And one thing I want to say about Advisor is that it's the freest type of interface you'll find on the internet. If you notice, I'm not logged in. I didn't have to give an email address. It's really free, as in you can just use it. So it's a great resource that's available. And you can see there's no, especially in the NPM universe, if you're looking for a particular technology, you'll find tens, if not hundreds, of libraries. So in the results here, I can look over on the right and I can say, well, here's Markdown IT, and it's got a package score of 89 out of 100. That's pretty good. I can see that it was published 5 months ago. If I scroll down a little bit, I can see that Marked has a score of 100, and it was published 22 days ago. Let's look at Marked. And the package health score here looks at 4 different dimensions of health. It's not just about security. Of course, that's super important, but it's also about community and maintenance. If I have a super secure library today, but a new vulnerability is discovered and there isn't a strong community, then maybe that vulnerability won't get fixed in a timely fashion. So that would drop the package health score. Now I can see that the latest version is 4.1.0, and then I can see all kinds of other information. I can look at the most popular versions. Sometimes the most popular version is not the latest, and sometimes the most popular version still has vulnerabilities in it. So that's something to look at as well. And I get all this information. This is awesome. If you're like me, what I used to do is I would go to the GitHub repo and I'd look at the number of stars and when the last commit was and when the last release was. Now that's a reasonable measure of confidence in a library, but this goes a step further and importantly shows me the security issues, the vulnerabilities, and in this case, there's no known vulnerabilities. Now, if you're scratching your head because I just showed you that Marked has this cross-site scripting issue, the reason is because I cheated. If you notice, the latest version here is 4.1, and the version that I'm using is 0.3.5. I'm using a very, very old version. So that's how I cheated. And back in the day, this is from 2015, by the way, so 7 years ago, Marked was not as strong a community. Today, it is, and if I'm looking at a search here, I'm going to go with the package that has the highest score, hopefully 100 out of 100. So out of all these Markdown libraries, I'm going to use Marked because why wouldn't I use the one that has the 100 on the package score? All right, before we leave the world of this application, I want to show you one more thing here. Like I said, this is a Java backend, and I have a controller here, and well, somewhere in this controller there is a vulnerability, and I would like to know, as I'm writing code, if the code that I'm writing is introducing security issues. The whole point of Snyk and of this session is to drive home the point that as a developer, you can start becoming aware and catching security issues earlier in the life cycle without you having to become a security professional yourself. So another tool we have in the arsenal here are these IDE integrations. Now we're looking at IntelliJ here, and I'm going to tempt the demo monster, and I'm going to run a scan of the code that I've written. So while we're developing, we can start to look for security vulnerabilities that we can catch before we turn over our code for a security audit or before we deploy. And I'll highlight this in just a moment. But if you notice, this is a multi-module application, and it's found vulnerabilities in my POM, and it's also found vulnerabilities in my package.json. So first of all, just within the browser, these are the library dependencies. It's found vulnerabilities both in the Java part of it and the JavaScript part of it. So that's super handy as a full stack developer. The other thing that it's found are issues in my code. Oh, it's still scanning. So that may be the demo monster biting me in the butt a little bit. Usually the scan is very quick. We can see down here that it says it's about 73% done, but I am going to let the demo monster have its way, and I'm going to jump over here to the command line because the nice thing about Snyk is that we can do, Snyk kind of meets you where you are as a developer. So if you live in the IDE, great, you can use Snyk there. If you live on the command line, you can use Snyk there. And I'm going to run this test on the command line, and hopefully the demo monster won't bite us here either. So it's analyzing the code. Come on, Snyk, you can do it. Oh, it looks like it's in a similar spot to what was happening in the IDE here. The IDE finished. All right, demo monster won maybe because it took longer than it should, but also us won because now we got the feedback. All right, so what is this showing me? Well, this is really cool. This is now analyzing my code and showing me where I have issues, and it highlights it kind of like a syntax error. So we see the red squiggly lines, and it's telling me this is very similar to what I showed you earlier. I have an issue here where I'm taking an input and passing it directly to an output. And the cool thing about this, and really I haven't seen anywhere else, is not only do we show you that there's this vulnerability, on the right-hand pane here, we give you these 3 examples of other live open source projects that had this same vulnerability and how those projects went about fixing it. So cross-site scripting, this is a very simple example, but maybe there's a vulnerability that you're not very familiar with, and you can see here with a standard diff how this project went about fixing the vulnerability. So this is super powerful, and we give you 3 examples of those fixes so that now as you're coding early in your software development lifecycle, you have an opportunity to fix these issues and to get rid of them. So in this case, it's using string escape utils escape HTML4, and even if I'm not familiar with that library, I can go do a little more research now. Now I happen to know that this is part of the Apache Commons package, so I might add Apache Commons and then be able to use this. But even if I didn't know that, I could do a Google search for this and come up with it pretty quickly. Let's see if this finished. It did finish. All right, so we got similar output from the command line. And while I'm at it, so now we've seen the command line, we've seen the IDE. Let's take a quick look at the website, and we get very similar feedback. So we have code analysis, and we have analysis of our various open source dependencies, and we see the same sort of feedback here. And if I look at full details, I get a very similar view to what I saw in the IDE. I can see where the issue is. It gives me specific line numbers, and I can look at the fix analysis, which we also saw in the IDE. So Snyk really meets you wherever it is that you work. All right, back to the ranch. Let's talk about breaches. So you may be familiar with the Equifax breach, since it's a European-friendly time that we're doing this session today. You might not be familiar with it, but this was a breach that affected consumers in the U.S., and there were 140 million consumers affected. That's about a third of the entire population of the U.S. And it took 76 days for it to be discovered, and it's cost $2 billion so far. Now, those stats are kind of shocking enough, but the real shock, and unfortunately what we see repeated all the time, is that this was the issue that was exploited with Equifax was a known issue that had a patch for it, and Equifax just didn't patch it in time. And we see this time and time again. And many developers are inclined, if they think at all about security, they're inclined to think of a vulnerability lifecycle as discovery, disclosure, patch, and we're done. But that's really, the disclosure is really the middle of the life cycle for hackers and attackers, because attackers know that there's going to be some lag between the time that a vulnerability is fixed and the time that all users of that library update their systems to incorporate that fix. So we have to take a bigger view. If you're like me, you think of your app as your code, but really your app's surface area is a lot bigger than that. It includes your open source libraries. And we're going to see in just a little while that the surface area is even bigger than that, because it may include container configurations or infrastructure as code configurations. And each time we add new technology in like that, we increase the attack surface, or potentially we can increase the attack surface. Let's take a look at a Spring Serverless example. So this is something we might deploy to AWS Lambda. We have this create to-do function in a to-do list application, and the function itself has 222 lines of code. Not bad, kind of a modest size function. And we know from our analysis that there are 5 direct dependencies. Now, we can't stop at looking at the direct dependencies. We want to look at the dependencies of those dependencies. So when we expand the entire tree, we have a total of 54 dependencies. So that's 5 direct dependencies and 49 indirect through the dependencies of those dependencies. So now, my question is, what do you think the overall surface area of this humble 220 line function is? So what do you think the resultant lines of code are? Drop it in chat if you would. I'll give you just a moment, and maybe Sonia can chime in if anybody's taken a guess. But what do you think with 222 lines of code, 5 direct dependencies, 54 indirect or total dependencies? What do you think that translates to in terms of the total number of lines of code as the surface area of this function? Feel free to take a guess. I'll give you the answer in just a moment. Now, I think I would have guessed, being, a chaotic neutral and kind of a savvy developer, I think I might have guessed, let's say 50,000 lines of code. That seems like, wow, that's a lot of code, right? But it ends up being nearly 500,000 lines of code. So the true surface area, if we're talking about lines of code, is not 222 lines of code. It's actually 3 orders of magnitude more than that. It's nearly 500,000 lines of code. This is the way we need to start thinking, not to scare ourselves or to halt development, but so that we can kind of bring security into the life cycle a lot earlier. Open source is a perfect target of attack because you have one vulnerability and many victims. If you can leverage something like struts, this was what enabled the Equifax breach. If you can find a vulnerability in struts, well, at the time, there were lots of big companies using struts, and it's likely that Equifax was not initially a direct target. What's more likely is that Equifax was involved in a large-scale probe to find out which companies were using this older, unpatched version of struts. And then once it was determined that Equifax had that version of struts, then it became a direct target of a focus to exploit. Now, another more recent one, which may have affected you, it sure affected me, is Log4Shell. So you might have had a similar experience to me. I was in Las Vegas for a conference. I was in the airport returning home, or I should say, I was at the conference on December 9th. Then on December 10th, I was at the airport returning home, and all of a sudden, my phone started getting hot from all the notifications it was getting. And when I took a look, I saw this emerging issue of Log4Shell. So 17,000 Java packages were impacted because Log4j is a very popular logging library. In our analysis, we found that 800,000 attempted attacks in the first 3 days. So from December 10th to December 12th, there were more than 750,000 attacks attempted because of Log4Shell. And we found that 57% of projects have Log4j as a transitive dependency. Now, if you're like me, you might have thought, well, I use mainly Spring Boot for my Java development, and Spring Boot I know uses SLF4j and Logback as its default logging. So I might have been inclined to think, well, I don't have to worry too much about this. And maybe that was true, but 57% of projects have Log4j as a transitive dependency, meaning we love our abstractions so much in Java that we can mix and match log libraries. And maybe I'm using an open source library that uses Log4j. So now I've introduced Log4Shell into my Spring Boot application through a transitive dependency. Just going to do a quick time check here. So, what presentation wouldn't be complete without a poorly drawn diagram? Here is my poorly drawn diagram of the mechanism by which Log4Shell works. So up at the top here, we have our logger. And imagine, we'd never directly drop in a string like this, but imagine through some mechanism, we could log out a string like this. Well, what happened from this point was that it hooked into the Jindy mechanism. Jindy is Java naming and directory interface, because in Java, we love our abstractions. And so we said, hey, DNS is a directory. Ldap is a directory. Let's have a common interface so that we can interact with directories. Ldap is lightweight directory access protocol. And what would happen here in a vulnerable version of Log4j is when this interpolation string was dropped into the logger, it triggered this Jindy stack. The Jindy stack could potentially make an external reference to some random Ldap server, in this case, evil.com. Now, when we think of Ldap, we usually think of devices like printers. We think of people and organizations, but it turns out that you can construct a perfectly valid Ldap response that is a reference to a Java object. So Ldap responds with a reference to a Java object. Back up here in Jindy land, Jindy happily resolves that remote Java reference. Now we make an HTTP call and we return a byte array which represents a serialized class. Jindy happily deserializes that class, and because that class is an interface, it's going to go and execute a method on that interface, and then we have mayhem. Maybe within the implementation of that interface, it tries to delete your whole hard drive. So this is what led to Log4Shell. Now you may be left wondering, how did such a critical remote code execution vulnerability even find its way into the humble logger? And it's actually quite interesting, if you ask me. And here we have the actual request to integrate Jindy into Log4j. And one thing I want to draw your attention to is that this request was made in 2013. And it was resolved also in 2013. So First of all, I want to take a step back and say, like, I'm not throwing any shade on Log4j or its development process or the contributor of this patch, because this followed a normal open source trajectory. A developer said, hey, I have this use case. Also, I'm a good developer and I'm going to provide you with a patch. I'd like this integrated into Log4j. It was reviewed, it was commented on, and it was integrated into the code. This is the great part about open source. It went through a normal open source process because a contributor had a use case that was useful for them and they thought maybe useful for other people as well. So this is how Jindy was introduced into this stack. So it was kind of sitting there dormant since 2013, which is the remarkable thing to me. It was sitting there for a full 8 years, and as a bit of a paranoid security professional, I have to believe that somebody was quietly exploiting it all along, and once it became known and public, that's when we got patches involved. So, and ultimately, the spoiler alert here is that they tried a number of different releases in rapid succession to keep Jindy safely in the stack. And when it became clear that that really wasn't going to be possible, they basically tore out Jindy and kind of rendered the log4shell issue neutral because you could no longer make external calls to Ldap. All right, we're going to quickly go through the log4shell stack here so you can see what's actually happening. I've set up some strategic breakpoints, if you will. But one thing I want to make clear right at the get-go, and let me just do something really quick because I forgot to do this beforehand. Let's make this a little bit bigger so it's easier for you to see. There we go. One thing I want to make very clear, and you know, the structure of modern Java apps allows us to do this, is this is a Maven multi-module project, and there's a separation between our client and our server. Now, the server has this class called evil, which we're going to look at, but that is not in the class path of the client. The client has no knowledge of this evil class. Evil is not in the class path of the client. That's a very important detail. Now let's fire up the server for this. Let's see if I've done this right. There we go. Whoop, I did something wrong. Aha, hold the phone. I am getting bit by the demo monster, but I know why. We'll come back to this in just a sec. Let's try this one more time. Aha, I still have something listening, I think on port 8000. Let's see if I can find that and shut it down. Bear with me a second. This is just the demo monster. Let's see. Let me shut down CTFD. I don't need that right now. That may be where I'm going wrong. Let's try this again. Hopefully that did it. Huzzah! All right, demo monster thwarted again. Now, what we're looking at here is I have a very lean Ldap server listening on port 9999 and a very lean HTTP server listening on port 8000. So this gives us the infrastructure for the exploit. We have Jindy, we have Ldap, we have HTTP. Now I'm going to debug the client, and let's just take a look at the client really quickly. What it's doing is it's going to show us some Java stats. It's going to do a very simple log message test. This is like a normal log message. It's going to check for the existence of a temp file. At this point, the temp file shouldn't exist. Then it's going to drop in this constructed Jindy string, and then at the end, the temp file should exist, proving that we were able to do a remote code execution. We were able to write some arbitrary files to the file system. So let's dig into it. All right, now we're in it. So we're in the middle of the stack here, and the first thing I want to draw your attention to is a response from the Ldap request. So at this point, if I take a look at my server, where is my server? Bear with me a sec. Okay, that's good. I lost my server. Hold, please. It is running, but where is my output? Oh, I ran it. That's why it's not debugging. Okay, so we sent the Ldap request, and now we've gotten a response. But where we're at in the debugger, and what I want to draw your attention to, is this Ldap response is perfectly legal. And it's got these attributes: object class, Java codebase, Java factory, Java class name. So importantly, it contains a Java codebase reference, which is a remote reference, and it's referencing this Java factory called evil. Let's continue. All right, so now we're in the middle of our directory manager object, and once again, we see these attributes as a reference class. And now we're at the point where, let me make this a little bigger. Now we're going to get this object factory from reference. So now we're in the middle of our directory manager, and it's going to reconstitute this object from this byte array that we got. So let's hop over that. And now we can see that the HTTP server returned the byte array, and now we have this thing called factory. And now by the magic of IntelliJ, we can see that our factory is of type evil. But if we look at what evil really is just an instance of this thing called object factory. So my client has no knowledge, no direct knowledge of evil. Evil is not in scope or in the class path of the client, but this stack knows how to deal with an object factory. When we have an object factory, we're going to call its getObjectInstance method. All right, let's continue on. So now it's going to call the factory's getObjectInstance method. And when we look at that getObjectInstance method, it's actually just going to end up returning null. The intention of an object factory is to return an object, but for the purposes of our evil doing, we don't care about that. We're just going to return null. Instead, we're going to construct a command that just writes a file to the file system, and we're going to use Java's built-in runtime to execute that command. And so now if I let this continue, now we're in our evil class, which again was not in the class path. It was through the magic of deserialization and interfaces that we got here. And now we can see that you've been pwned. We were able to successfully do a remote code execution because of this, this issue. So here's the thing. Here's the kind of wrap up of this section. On December 9th, your Java code was perfectly fine as far as you knew, as far as the world knew. On December 10th, that was not the case. And if you happen to be using Snyk for your Java application, you would have gotten a notification saying, hey, there's this new vulnerability you need to update. It's an evolving situation, but go here and here's the latest and go update log4j. Now we also have this great cheat sheet for log4shell, which you may or may not be aware of, and I forgot to bring it up. So let's see how quickly I can find it. Haha, Log4Shell remediation cheat sheet. So we have this great cheat sheet, and it goes through in order, the various ways to mitigate Log4Shell. And the most important one is to just upgrade to the latest version, 2.17.1. But there are a whole bunch of other mitigations in case you couldn't do that right away. All right, let's continue on. We have a little bit more time together. Working our way, continuing down the iceberg, the next level is containers. And in the last 10 minutes, we're going to talk a little bit about containers and touch on IAC. Now imagine, if you will, that with these top two layers, with code and open source, you've driven out all the vulnerabilities. No more vulnerabilities, everything's great. And now we're going to deploy to a container. Well, this expands the attack surface, because now you might, while your code and its libraries are perfectly great, you might have a vulnerability in the container definition itself. Maybe you're using an older version of Linux that has a bunch of vulnerabilities in the utilities that are installed in your Docker image. Or maybe you're using an older version of Tomcat, so your code is safe, but the container that it's running in has vulnerabilities. Now, when we look at vulnerabilities on Docker, and again, we love Docker, not casting any shade on Docker, but I used to tell my daughter when she was younger that the internet is forever. Well, Docker images, Docker Hub are kind of forever, and we find that older versions of these images have lots of vulnerabilities in them. We also asked in a survey when developers scan their Docker images, and fully half of them said we don't. And how do you find out about vulnerabilities in your deployed containers? Almost half of them says I probably won't. So we want to arm you as a developer who's using Docker with the tools that you need to be able to have a high degree of confidence that your Docker containers are safe as well. So let me kill all of this. I think that's all that's running. And I'm going to bring back up the thing that I killed before. And let's go and show another little example here, and we'll kind of wrap up with this. Okay, so what we're looking at here, inside of a Docker container, I have this to-do list application. It allows you to sign up or sign in. It allows you to create to-do list items. You know what? We're going to ignore that altogether, because let's assume that this application and all its dependencies are completely safe, no vulnerabilities. Awesome. But I've deployed it to this Docker container, and this Docker container, or I should say Tomcat running within this Docker container, has some vulnerabilities. So let's just take a quick look here at our Dockerfile, and there's a couple of things we can see. One is that I'm using this version of Tomcat 8.5.21. All right, everything else looks pretty standard here. I'm deploying some Java code directly to Tomcat. Pretty straightforward. So I'm using this image, and I'm deploying this version of Tomcat. All right, not bad. Now let me bring you right to the punchline, and let's tempt the demo monster once again. Is this the right one? I don't think that's the right one. I think this is the right one. Let's see. What we're doing here is two things. One is we're using this Docker file that I just showed you as a hint, but it's actually analyzing the running Docker image directly, and it's looking at all of the utilities that are installed and all of the additional libraries that are running, like Tomcat. Okay, good. We thwarted the demo monster once again. Now, if you notice, Tomcat 8521 has no fewer than 735 vulnerabilities. That is a lot of vulnerabilities. Now, if you notice here, if I upgrade simply to a minor version, that drops by about 600 plus vulnerabilities. That's pretty good. Even better, if I change my base image, I can get to the point where I have no vulnerabilities at all. That is the best, right? Now, sometimes we find ourselves in a position where we're dependent for whatever reason on these older versions, but at least we can drop the number of vulnerabilities. But if I can upgrade to one of these other ones, I get 0 vulnerabilities. So the big punchline here is that simply by bumping the version in my Dockerfile, I go from 735 vulnerabilities to 0. That's pretty awesome as a developer to get that kind of juice out of a change. Now, this repo that we're looking at here is entirely open source. Just in the interest of time, I'm not going to actually show you the exploit, but suffice it to say that with 735 vulnerabilities, there is an exploit. But the good news is that all of these examples that I've shown you today are available on our Snyk Labs instance, which is has a lot of open projects. Now, if you do a search for goof, a whole bunch of stuff comes up. We name these goof because we wanted to ensure that nobody was going to accidentally treat them as some sort of production code. But here you can see Snyk Chat goof. We also have Java goof, which includes this to-do list goof and the Docker file that I just showed you. So it's really easy to play around with these, to scan them, to fix vulnerabilities, to see the vulnerabilities go away when you fix them. So I want to encourage you to do that. All right. Last layer of our application, which we're not going to be able to get into with any detail today, is IAC, infrastructure as code. The important thing is that the number one cloud vulnerability, according to the US's NSA, is misconfiguration. So the simplest example of this idea is, maybe in your Kubernetes containers, you have everything running as root. By the way, that's the default. You need to add some code to your configuration, a couple of lines of configuration code to make sure that everything isn't running as root. So those are the kind of things that are easy to overlook, and that Snyk's tools, just like we saw with code, open source, and containers, there's a Snyk command for infrastructure as code, and it will let you know of those kind of issues as well. So to wrap up here, what's the solution? Well, I showed you some parts of the solution, and you might be inclined to think, well, great, the solution is tools, right? But actually, a complete solution involves more than that. You have to have a culture that supports developers bringing security into their practice. You need to have processes in place that bring those security practices to bear. So many years ago, developers were resistant to the idea of testing. And if we fast forward to today, we can't even imagine a project where we wouldn't have testing and where we wouldn't have testing be part of our CI/CD pipelines. It wasn't always the case, by the way. If you're old enough like me, you remember a time when developers were very resistant to the very idea of testing. Well, we want to treat security the same way. We want security scanning to be built right into your CI/CD pipelines so that you can automatically get the same kind of feedback that you do from tests. So we need culture, process, and tooling. Tooling is just one part of it. And with all these three together, you have a powerful solution to have developers bring security into the entire software development lifecycle. So all along the way, and I kind of ironically, everything over to the right here is often neglected, but you can have active monitoring of your production systems as well. And like I said, if you were a Snyk user, if you were a Snyk customer, and you had log4j deployed in your production environment, and you were monitoring it in the way that we recommend, you would have gotten an alert that a new vulnerability was discovered on December 10th, 2021. So shifting left is not enough. We don't want to just shift left. We want to have this kind of virtuous feedback loop where you have culture, process, and tooling that empowers developers to build applications securely from the get-go and throughout the entire development process. All right, so thank you very much for joining us this morning. I really appreciate your time and attention. This is going to be available on our YouTube and Twitch channels if you missed a part or you want to revisit it. And with that, I will let you all go. Thank you very much.
Thanks, Micah. Hope everyone enjoyed today Strange Dangerous session and hope you learned something new. Thank you for tuning in. Don't forget to subscribe to the YouTube and Twitch channel to check the other sessions and show that we have to learn more about security. Thank you all. Thank you all for tuning in. Bye.